Which of the following property of proton can change while it moves freely in a magnetic field? So there are four options. My request is think over. It's okay to not know the answer. At least think over. Think over what can be a possible answer and what can't be a possible answer. If you're sure of one of it, at least that, okay, this is not an option for sure. Even that is a good step, right? So that means you have understood some aspect of physics. So again, don't take this question as just getting the right answer, but at least eliminating the possible non-answers. So option A, mass. See, mass is something that we have kept telling, that difference between mass and weight is that mass is fixed and weight of a given object depends on the gravitational pull and all that. So for what we are studying, the level we are studying, mass is fixed. Okay, we're not talking about anywhere moving at a speed of light and all of that. So some weird things happen over there. But yes, as of now, mass is fixed. So no point of time for anything that we do, mass will change. Right? So this is not an answer. Next is speed. When will speed change? Let us discuss about speed. See, if I have an object, say it's at rest or it's already moving, if I want to accelerate it, means what? Change the speed, actually velocity. If I want it to speed up, what should I do? Basically, if I'm, say this is a toy car, I'm pushing my nieces or nephew around, right? So what is that I have to do? I have to push harder. Then it will speed up. So basically, force is a factor to speeding up. And what did we see? A proton will, or any charge, moving charge, will experience a force when exposed to a magnetic field. Okay. So does it mean the speed will change? Well, the nature of speed force is that it is always perpendicular to the motion, is it not? So we have seen this. We always kept talking about magnetic field, current, and the force being perpendicular to all of it. They're mutually perpendicular, remember. That's what Fleming's left-hand rule tells. Since the force is mutually perpendicular, it won't experience a force in the direction of the motion. Right? Let me write that as the force is perpendicular to motion of the charge. It cannot change. Yes, it cannot change. It cannot change the speed, is it not? See, if I want to speed up to the right, I can't start pushing from left or this end or that end, right? If I want to push it, I have to push it in the right direction. If I want to speed up or speed down, either I have to go back of the vehicle or for front of the vehicle or the toy. In the sideways, if I purely sideways, I cannot do it. Make sense? So speed, I can increase or decrease only by pushing forward or backward, right? So if that is the agenda of it going forward or backward and no other direction, I either have to push from the back or the front to make it go faster or slower. So in this case, even though there is a force, the speed factor will not change. But yes, what is changing? It cannot change the speed, but it changes the direction, right? It changes the direction, is it not? If I happen to push from that end, it might not speed up or speed down, but certainly it will change the direction in which it is moving. So with this in mind, we'll talk about velocity. See, velocity is a quantity which has one of the factor is the magnitude part, which can be related to speed, and other one is your direction, right? So velocity is a what quantity? It's a vector quantity. So since we saw that speed cannot be changed, so that's not an option, but direction is changing. So we have written the explanation over here. Same thing over here as act again. As this force is perpendicular to the motion of the charge, it cannot change the speed, but it changes the direction. Thus, the velocity will change. So what is the question? Which of the property of the proton will change? The velocity factor will change. When I tell speed is fixed, but the velocity is changing, means what? The direction is changing, right? It changes. Make sense? Now, momentum. So I hope you guys know the momentum formula. Momentum is mass into velocity, right? Since velocity is changing, okay, I think I have to, okay, let me write just V. Since the velocity is changing, yeah, it has to be V. I was writing it, thinking about voltage. Since the velocity is changing and momentum is a product of mass and velocity, right? And this too is a vector quantity. So yes, even the momentum will change. So answer is option C and D. Okay, so this is your answer. So pause and think over. If you guys didn't get a particular point, right? So let us know. I'll try to remake exclusively, including those points in which you guys have not understood. So pause and think over.